Hello, welcome to my channel. In this video, we are going to be solving problems under photoelectric effect. So, one of the problems we want to solve is given in the form of this statement. So, we have a light source with wavelength 512.3 nanometer falls on the metal and a stopping potential of 0.456 volts was needed to reduce the photocurrent to zero. What is the work function? So to solve this problem, first of all, we produce the formulas needed to solve problems under this topic. So the four formulas that we are used to is giving us this. So we go back to the question and find out what are the parameters that are given. So we have the stopping potential, we are asked to calculate the work function. So if you check your formula, we have stopping potential, we have work function. So we eliminate this because there is no work function here. So, but if you look at this, we have stopping potential, we have work function. So therefore, our third equation is the right equation to use. So we produce our equation, right? So at this point, we're asked to find the work function. So which is this? And we have our HF, which will reduce to HC all over lambda equal to 5 plus our electron volts, right? The stopping potential is giving us 0.456 volts. So we have 0.456 volts with the electron charge, right? Our wavelength is given. Recall that our HF is also can be written as HC all over lambda, right? So, and our HC can also be written as 1240 electron volts times nanometer, right? So at this point, nanometer will take care of nanometer. This will divide this. Our answer will now be in electron volts. So we have 2.42 electron volts equal to this plus this. So if you make file the subject formula, right, we have this minus this equal to 5, and that gives us phi equal to 1.964 electron volts. Right, so we move to the next question, which is we have if the photoelectric threshold wavelength of a metallic surface is 272 nanometer, calculate the maximum kinetic energy of the electrons ejected from the metal surface by ultraviolet radiation of frequency 1.45 times 10 raised by 15 hertz. Express your answer in electron volt. So as usual, we produce the four known equations for solving problems under this topic. So we have this. Now, we're told that the threshold wavelength is given. So when we get threshold, remember this formula, because our F naught here is a threshold frequency, and we can get our threshold wavelength from this. So we need this. If we use this one, we can calculate the work function. So the question is calculate the maximum kinetic energy. So maximum kinetic energy is from this particular formula or this one. But if you look at this one, we are asked to calculate this, and we know information from this one. If we get this, we can slot it here to calculate this one. And since we are given the frequency of the radiation to be this, so we'll combine this equation, the second equation, and the fourth equation. So to do that, let's start with this fourth equation, which can be re-expressed as HC all over lambda naught equal to 5. We have this. We already know our HC to be 1240 divided by the threshold wavelength. So we have this expression equal to 5. So our phi becomes 4.5588 electron volts. So now that we have our phi, we can slot it back into this expression, right, by making K max the subject formula. So it becomes HF equal minus phi equal to K max. So we have K max equal to HF minus phi. So we already know this. We are looking for this. Now, we know our frequency of the radiation, which is this. So we can multiply with this. So what we can do is to first of all take care of our HF first. Let's solve for HF first. So our HF is this expression times this. We can see 1.45 times 10 raised by 15 with our Planck's constant. So if we multiply this, it gives us a final answer in joules. But what we have is the file in electron volts, and we're also asked to express our answer in electron volts. So our K maximum is also needed in electron volts. So what we do is to convert these joules to electron volts. And to convert it, we use this conversion factor. And if 1 electron volt gives this, we can find this in electron volts, right? Just by dividing this one by this, and we'll get our answer. So we get our HF equal to 5.997 electron volts. So now that we have our HF, we can slot it back into this expression. So we have our K max equal to this, which is HF minus the work function, and that gives us 1.44 electron volts. So we have finally this equal to this. So that's it. So let's look at the third possible questions. The third possible question. So we have a clean nickel surface having work function of this is exposed to light of wavelength this. What is the maximum speed of the photoelectric electron emitted from the surface? So we have the same formula. And from what we have the work function. So there's work function, work function, work function. And we have a wavelength of this. What is the maximum speed? So maximum speed can only be gotten from the kinetic energy. So we have the work function. Maximum speed can be gotten from the maximum kinetic energy. And we have a wavelength of the radiation to be 235, right? Which can be used in this particular, which can be replaced here. So this expression, the second equation, is the right equation to use. So we have K max, making it the Soviet formula, equal to HF minus phi. Okay, so remember our HF can be replaced as HC all over lambda. Our work function is given, so we can go ahead and say HC all over lambda minus phi. Our HC is 1240 divided by the wavelength, which is 235. So we have this expression divided by this minus the work function. So at this point, if we divide this by this, we have this minus 5.1 equal to 0.1766 electron volts. So now that we have our K max to be equal to this, we use this particular expression to convert this electron volt to joules, because for us to calculate our velocity, we must convert this one back to joules, and using this one, we get K max equal to half of mv squared equal to this joules. So we've already converted this towards joules using this conversion factor. Okay, so at this point, we can make our V the Soviet formula. We have our V, 2 comes here, m goes down, which is the mass of the electron. Then we take the square root of everything. So at the end, we have our V to be 2.49 times 10 raised to 5 meter per second. And that's it. I hope this helps. Please like, share, and follow for more. Thank you.